Hello colleagues, my name is Alexander Zelenin. I'm software engineer with more than 15 years of experience. Today we will observe Manachar Algorithm. This algorithm provides the linear complexity for finding longest palindrome in string. In the same time we will go through the simplest approaches and we'll try to understand why this one is better than other ones, why it's faster, and how it works. So we'll start from observing the problem itself. So let's start from the problem that we need to solve. So we have a string and we need to find the longest palindromic substring. Palindrome is the string that can be read from both directions the same way. So for example, BAB, it doesn't matter. Do we start from the first B or from the last one? Like from the first to last or from last to first? It will be the same. So mostly that's all. We need to find the longest palindrome substring in the string given to us. In this condition we have maximum length of 1000, but it might be much more. Also this problem is can be subset of other types of problems. So let's start designing some algorithm. So let me write down example. So here is one of examples I had prepared, and let's start by finding palindrome as a human, as ourselves, like what we need to do to find the palindrome in the string. We can start with every letter we can start with some substrings and check is they palindrome or not. So for example, we took first two letters and check is they a palindrome. No, they are not, because the letters are different, they are not symmetric. Then we can took three symbols. Check it again. No, it doesn't work again. We repeat this operation until we go to the last one. Then we repeat this operation with less amount of symbols, and so on. So we can repeat this operation a lot of times, and in the end we will have a solution. For example, we can find a palindrome like CXC or CXCB, CXC, like this one, or even larger one. So what is complexity of this algorithm? First of all, we are generating substrings from the start to end. So we have one cycle for first letter and one additional cycle for the last letter to have all combinations. So by itself it already have n square complexity. Plus we need to check the string itself. Is it palindrome or not? Which also took up to an operation, since we need to check up to all letters. So total complexity of this approach is n cube, which is super huge. 1 second, let me open the chat. Yeah. So we have n cube, which is huge. We can try with another approach. We can, instead of creating a substring every time, We can start with every letter as a pointer to middle of the palindrome. So for example, we're starting with letter B and we're checking A and checking C. They are different, so we skip this one. Okay, then we go to next letter. We start with C. We compare B and X. They are different, we skip this one. Then we go to X. Okay, C and C is equal, so we found a small palindrome here. And we continue. We compare B and B. They are also same, so we find a larger palindrome. Then we compare A and C. So we're done in this. So since they are different, we found a palindrome BCXCB. What is complexity of this approach? Since we starting with every letter, so we have a cycle that go n times, and for every letter we expanding in both directions. This expanding can take up to n times, since we can extend up to the first and last letter, so it's another n. So with this approach we'll have n squared. So like what we can do with this? So let's try to find the optimal solution. Exactly, we knew optimal solution. This the algorithm we will have talk about today. And we'll observe this algorithm and find out why it's good and why it gives linear complexity. But it based on this one with one huge optimization regarding caching. So the first problem with this approach is that we need to go not only for every letter, but for in between of letters, because we can find a palindrome of 2 letters or of 4 letters. I think there is no 2 or 4 letters palindrome, so in this case it will not work. But generally you can find like AA or BAAB or something like that, something like this. So we will need to go through like every letter and in between the letters. To avoid this problem of writing like 2 algorithms, we can extend this string into the largest one that guaranteed has odd number of letters. We can do this by adding additional symbol after every letter. We adding symbol that doesn't exist in our original string. One second. Yeah, we will get long string in this case. So XCB DA. Oh, let me make it smaller. And in additional, we add the one symbol at the start. So we multiply count of symbols by 2 plus 1. So it doesn't matter how many symbols we have initially. In the end, we will end up with like x2 plus 1. It's guaranteed odd number. So for example, if it was 10, we will get 21. If it was 11, we will get 23 symbols. And we will go through this string for every symbol, including the new ones. So we guaranteed go like in the middle, and we can compare the letters from left and from right side. What is the difference with the previous approach? the difference is caching system. What we can cache here. So let me start by defining some basic things that we will use here. So the first thing we will have here will be center of our largest palindrome that we're observing right now. And the second variable will be window. The current window of our palindrome is in our string. And let's also have the third one. It's current index. The index of the element that we are checking right now. So how it will work? Let's start with the previous approach, but with our new string. And when we get the first palindrome that greater than 1, I will explain. So we start with the first symbol. We can skip 0, 1. 0 doesn't matter because it's our new symbol. And we will filling new array. New array will be the same size as our new string. So for every letter, we will have additional integer. This integer will represent the length of palindrome at this position. So for example, for the first symbol, it will be 0, since there is no palindrome. When we go to 1, to index 1, to letter A, we compare the symbols near A, and they are the same, so the length of this palindrome will be 1. Generally, every second letter will have at least 1 length. And in this case, we'll have center of palindrome with index 1, and we will have palindrome itself like this, and the window length will be also 1. The window, by window, we will name the length from start of palindrome to the last symbol. So in this case, it's just 1. Let's go a bit further. So for next one, we have 0. For B, we have 1, then 0, then we have 1, then we have 0, and here fun starts. So we have x, which is index 7 right now. And we starting to find our palindrome. We see that this symbol is same, this symbol is same, this symbol is same, and again B is same. And also the symbol after B also same. So we'll have, let me change color to different one. We'll have a window like this. So we start from 7 and up to 8, 9, 10, 11, 12. So we have an index of 12 here. So our current index will be 7. Our window will be 5. So 12 minus 7 is 5. Since we have 5 elements after our symbol. And from this point, all our fun of this algorithm starts. So we write our window length here as 5. And when we will go for next actions, so let me change color to blue one, for example. So when we go to next one, when we operating under the window, in this case we have like 5 in one direction, and we have totally same amount in another direction. In this case, since we knew that the left side of this window a mirror of right side of this window, right side for like this. So this symbol will be equal to this one. This symbol is equal to this one. It's guaranteed by definition of what we had found. It means that minimum size of palindrome at every position will be the same as the one on the left side. So in this case, this add symbol will have minimum the same size of this one, but this one is already 0, so it doesn't matter. So we start calculating and it will be again 0. So we have just one check. But with C it will be a bit funnier, since C have already length of 1. What does it mean? How we can use this information? We can initially skip this amount of symbols since they are guaranteed to be same. So we starting with palindrome like this, and we need to just make one check of comparing B with X. B is not same to X, so in this case we have again length of palindrome of 1. We repeat same operation for add, it will be again 0, but with B it will be much funnier again, since we will start another palindrome here. So what happens here? Let me again change color. No, not yellow one. Yeah, let it be like this. So we again start with 1. So we selecting this palindrome and start comparing the symbols after this. So we comparing C with C, they are same. We comparing next symbol, they are same. So we continue this operation, and this window will go beyond our previous window. So we will define our new center and new window. So let's see what we will have here. So we start with B, and we will have at C. Let me remember where it ends. I think it ends here, right? After B. Yeah, like this. So 1, 2, 3, 4, 9. Okay, 9 symbols in both direction. So we have window of 9. And the last index, so here we have 11. And the last index is 20. Since our new palindrome, our new window is far away than previous one, then we define the new center. So in this case, center will be 11 and the window will be 9, as we had calculated previously. So we had found a pretty large palindrome, but what will happen next? We continue to find palindrome after this one for every symbol. So let's continue and until we'll go to up to the one that give us 5 lengths up to this, up to X. So we'll have 0, 1, 0, and now we go to X, which have the same size as 5. So we can start in this case with the same size. So we're starting with the window of 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So this red one. And we don't need to check all of elements inside of the window since they are guaranteed to be the same. This is like big safe. So we can start by comparing only elements after this one. So we're comparing D and C. And they are not the same, they are different. So we do only one check for pretty large string, and like complexity for checking this one, it was just 0.1 in this case. Like we check only once because of our caching. So the length will be the same. The length will be 5 in this case, since it's not larger than previous one. We already had checked it by checking additional symbol. So we continue with symbols up to an end. We will have same 0, 1, 0, 1, 0, 1, 0, 1, 0, right? Yeah. So what happened right now? How many operations we perform? For every palindrome that we try to find where we have 0, we perform one operation to search it. Where we have 1, we perform 2 operations. So we check the nearest symbols and then 1 times more. Then, when we had the big palindrome for first time, we perform like 5 operations of comparing. Then, for every other under this window, so for example, for this one, we make not 2, but just 1 operation. And because we have cached value and we'll start with like from the second one. Then we going to the bigger one, which is 9, and it starts with 3 symbols, because we cannot go like we're operating under this window all the time. So, but anyway, we do less operation than it give result to us. So 1, 2, 3, 4, 5, 6, 7, 8. We do 8 operation. Instead of 11, we do 8 operation in this for this letter. By the reason of we already have sorry, instead of 9. So there is not too big safe, but the big safe go for the next letters. For every letter under the window, we again make just 1 check, and even for the letter that have pretty big palindrome, we still make just 1 check. So for every letter under the window, we either increasing our new window that give us caching ability for us for next operation. Even we do only one operation, and that's all. So we have one array of integer which have space complexity of on, and we go through every element just once. Like maybe for some of them we go like twice, but not more than twice. So generally it's like O to n, but we can drop 2, so we will have complexity of n. Okay, I hope the algorithm itself is clear now. If no, write to chat, please, ask questions, and we will go to the code itself and observe how it looks like, the code itself. So let's go to code. We have two methods here. The first one is to get palindrome length at some place. So let's observe this code and let's find the space and time complexity. Space complexity and time complexity. So space complexity here will be just 0.1 since we doesn't store anything inside of the code. Let's observe the method itself. So we accepting the string and our center. We will checking that we have index. The index is the letters that we are checking right now. And initially it will be equal to the skip value. So we dividing the index from the center and checking that we are still in the array itself. We are summarizing center plus index and see that we still in the range of array, like not exceed of it. And then we compare element by plus and by minus index. So like previous and next letter, plus 2 letters, minus 2 letters, plus 3, minus 3. And if they are the same, we increasing our index by 1 and repeat this operation until they are not the same. And we returning at the end index minus 1. Minus 1 by the reason that we want to remove the first symbol itself from the result. So we want to get only right part of it. So we perform this operation until this criteria is broken. So like in worst case, all symbols will be the same and we will have ON. So time complexity for this will be ON, but only if we doesn't take skip argument in account. So it's for skip equals 0 will be ON. Let's go to the main code of main function. So to find longest palindrome, we have string s, and first what we do is generate string which is x2 plus 1 length. We adding new symbols which is not equal to one that use it in our char set. So it can be not just at, it can be any symbol that guaranteed not use it in our string. Then we have 3 variables: center, window, and palindromes. So we start going through through our string and filling our palindromes. So we going from the first symbol to the last one. We start with the skip one because we want to skip the symbol itself. Like symbol is equal to itself by definition. So like if index will be 0, if skip will be 0, we will compare just symbol with itself, and it doesn't matter at all. Then second part, we have end of our current window. Remember that previously we have calculated window of long palindrome. So we can find the end of current window by summarizing center and window size. So we will find the last index that represent end of window. So if our current index under this window, so before the index of the end of the window, then we can find our skip value. The skip value will be equal to, let me go again here. So the skip window, in this case, for example, when we come here, it was 1. Okay, it's not so interesting. I think in this case we doesn't have a good example to show. But the idea that, for example, if for example for this b, let it be not 1 but let it be 3. By some reason we have just additional symbols. We cannot go later than further than end of the window. So we will start at this point. We cannot go further than window because we doesn't know what is later. Because if it will be possible, then we will have just larger window if symbols after this will be same. So in this case we have length only of 1 instead of 3. So let's go back to code. So we have 2 options. Even we go to the left to find the same symbol, even we just go to end of our window. So end of our window minus current index will represent the length under the end of the window. Generally, yeah. So and this part, let me open graph again. By this part, so for example, we are currently at b and we want to find previous value of x. So let me change color to this one. So we have index of 11 and here we have index of 15. So between them there is 4 elements. We want go to the left for 4 elements to find the 7, right? 11 minus 4 is 7. So we can do it by this way. 15 minus 11 give us 4. 11 minus 4 give us 7. So generally speaking, we have 11 multiplied by 2 minus 15. So because we had used it twice. So let me just repeat. We have 15 minus 11 and this gives us 4. And from 11 we remove 4. So we can just drop the brackets. We'll have like 11 minus 15 plus 11. So we have 2 of them. So 11 twice minus 15. Hope it's clear. So we took element from like our left part, from our middle, or we got the maximum length until end of the window. So, and we start calculating our palindrome. And we're providing our skip. So we're providing our string, our current index, and skip. After we calculating our palindrome length, we saving it in our array under its index. And we calculating end of new window of our new palindrome by just summarizing I and length. Highest index of current palindrome. So if end of new window is later further than end of old window, then we changing our center to the new letter and changing the window itself to new palindrome length. Okay, so we repeat this operation until the last symbol. as we had the talk before. So let's take a look what complexity will have. First of all, let's have complexity of string generation. We will have space complexity of on, since we have like 2n plus 1, which is generally on. And for time complexity, we also have on here for generation. Then we have cycle that go through every character. It has space complexity of on. Generally, this variable, this structure will have space of on, since we saving for every character additional symbol, additional integer that represent length of current palindrome. So we can ignore space here. So we have time complexity of on for the cycle itself, and inside of cycle we get the length of palindrome. So, but this one also have on complexity, right? So we end up with n square. And like Alex, what you had explained right now to us, why you explain that it will be linear when we have n square? We doesn't have n square here. It's trick. Because of the skip, we had observed it in previous part when we observing design of algorithm itself. So if the skip will be always 0, then yes, we'll end up with n square. But with the skip, we end up with just linear time. So every element will be checked maximum 2 times. So it will be maximum like 2n. So which is still on time complexity. So nice. But we need to find the last step, the longest palindrome. But since we have array, let me open again. Since we have our array, this one, this one. With all numbers, it's super easy to find the biggest number in array, right? So we just go through all of them and find that 9 is biggest one. But it's not all. We need to make one additional action. It's not too complicated, but still required. So we need to find the proper index from our initial string. So we will create a small structure, or 2 variables if you want, the start of our palindrome and length, original length of it. So we will go through our palindrome length and compare it with the longest one. We always will start with the just one symbol, the first symbol. So we have for every string, not for every non-empty string, we will have a palindrome of just one symbol, like always. It's minimum, because symbol equal to itself. So if length is greater than longest one, we start calculating the start from our original string. We can do this by subtracting from the index, from the current index in our array, our length, and divide result by 2. Because we had increased our length by 2, we just divided by 2. Done. Like nothing special. And what is interesting in this case, that we have the same length. So let me show this. For example, we had 7 here. So we had 7 here. And we had calculated the 7 by going only to right. 1, 2, 3, 4. No, sorry, 7. It was index. We have 5 here. We have 5. 1, 2, 3, 4, 5. But what is interesting that we have only 5 symbols here: B, C, X, C, B. So when we go only to right, we calculate exactly amount of symbols in our original string, because we don't want to go to left, we just ignore this part, since we have double of them plus one additional symbol. So this way we had found everything. So, and the last step, of course, is to, let me write complexity also. So we have another ON complexity for this operation. And the last operation is getting substring from original string from start to end. In worst case is the same or just one letter smaller, so it will also can took up to ON. So generally we have only ON complexity everywhere, and there is no cubes, no squares, so we end up with linear complexity. Let's run our code. Let's submit it to LeetCode. We had pass all tests. Our runtime is beats all submissions. Not all, sorry, like 95%. So only one of 20 submissions equal to the same one. I think we also can resubmit it, because sometimes LeetCode show the different values. But okay, it's around 90%. So we end up with the fastest possible approach. I think it was fun. I really like this algorithm. It looks interesting. And I hope with this approach of Windows, it looks very clear, because I had seen some explanation with just variables of one letter, and I had understand like nothing. So it took some time for me to get to this position. So thank you for watching. Please set like, subscribe, write comments what you think about this format. If you will like it, I will give more explanation about some interesting algorithms. If it's not interesting, send dislike. Why not? It will show me that I need to change something. So thank you for watching and have a nice day.